station. This is Houston. Are you ready for the event?
Good afternoon. We're ready for the event.
Carver High School. This is Mission Control, Houston. Please call station for a voice check.
Station, this is Congresswoman Terri Sewell at Carver High School in Birmingham, Alabama. You hear me?
Carver High School, this is Mike Fossum on the International Space Station. I hear you loud and clear.
Well, Astronaut Fossum, we want to thank you for taking the time to speak to our students today. We're really looking forward to both an inspirational and informative session. Our students will ask the questions now, and they will introduce themselves, what school they're from, and ask their questions.
That's great. I'm ready.
My name is Brianna Erskine, and I'm from James K. Middle School. Is it difficult to leave Earth for a long period of time?
Hi, Brianna. Good question. I think for me, the hardest part for me is leaving behind my family. I'm married, I have 4 kids, and I have a granddaughter now, too. So it's hard for me to be away from home for a long time for those kind of reasons. But I think what I'm doing here is worth it, so I'm glad to do it.
My name is Louis Owens from Hudson K-8 Middle School. How long do you have to train for NEF? How are you going to?
Hey, Louis, it's a great question. How long do you have to train for a mission? The training goes on for many years. It really started when I was in school, just like you, as I began an interest in math and science and technology, and began actually laying the basics or the foundations for my mission up here back when I was in grade school. After you go through college and work and are selected as an astronaut, well then for a space station mission like this, it was intensive training for 2.5 years of dedicated training before I launched on this mission. Which is a long time. So you take 2.5 years of training and then almost half a year in space. So that's a 3-year chunk out of your life, and it is wonderful. I'm enjoying every minute of it, of the training, and now every minute of the mission.
I'm Takia Badell from Inglewood K-8 School. How long does it take the space station to travel around the Earth?
Mina, that's a really good question, and it's kind of surprising. It only takes us 90 minutes to go all the way around the Earth, just an hour and a half, because we're going over 17,000 miles an hour, or about 5 miles a second. And so it's really pretty amazing to look out the window, and I've done this a few times when I had time on a weekend to just watch the world go by and to see an entire day in about 45 minutes, and then nighttime also about 45 minutes. So it's pretty cool to see that. So knowing whether it's light outside doesn't make any difference to us, because it doesn't get dark at night here. When it's time for us to go to bed, the sun is still shining bright, and we're still going around the Earth having a day and a night every hour and a half.
Pretty cool.
My name is Santiago Romero, and I'm an 8th grade student from Wilkerson Middle School, and my question is, when you are on the space station, what prevents everyone and everything from being sucked out into space?
So the answer to that is we don't open the windows. We have windows. These are windows right behind me, but there's no way to open those windows. There's a cover on the outside, and sometimes if you're listening to NASA TV, we might talk about opening the windows, but we're not really opening the windows. There's a cover that helps protect the windows from being damaged by something, or sometimes we want to keep the light from getting too much sunlight or heat from getting in. And so the whole space station is sealed up, and to keep all of the air inside. And that's really, really important. And anytime we're doing something, we do have little vents that go outside, and we have hatches like when we do spacewalks, or have a hatch to the space shuttle, or a hatch to the Soyuz spacecraft, or one of our cargo ships. And we spend a lot of time to make sure those are sealed perfectly so we're not going to leak air through those things. Now, if the hole got punched in the wall right behind here, then the air would start rushing out of those holes. And if it's a big enough hole, then we're all going to get sucked out of it. So it's all designed so we're not going to get holes in the wall. It makes for an exciting scene in a movie, but fortunately that kind of thing doesn't happen up here.
My name is Aaliyah Terrell. I'm from Daniel Payne Middle School. What happens to rockets when after they have finished with their missions?
That's a really interesting question. What happens to rockets when they're finished with their mission? It depends, but in general, the rocket you could think of it as being made up of a few different pieces. And the first part is the rocket with all the fuels and the big rocket engine to get us off the ground and up into space. And those typically come in separate sections too, and when they burn out, when they use up the fuel in those sections, those things fall away. Now, the space shuttle kept its engines and brought those engines back to the ground to reuse again. And just the big orange fuel tank fell away and was actually burned up as it fell back into the atmosphere. With the other rockets, like the Soyuz rocket that I came up on, it has some stages, or some kind of like rockets stacked on top of each other. And the first ones you burn are the really big ones at the bottom, and those fall away, and the next one lights, and it keeps pushing you up further and further. But the short answer is that today there's very little of rockets that are very little that's reused. You've got the rocket part that pushes us up, and then there's the part that we're in, the spaceship part of the rocket that has the humans, on the top, and that, of course, makes it all the way to orbit, is attached to the space station right now, and then when we go home, that protects us from the incredibly hot temperatures as we're re-entering the atmosphere to come home to Earth. And a few pieces of that spaceship get reused, but most of it goes to a museum or goes to recycling.
My name is Jamir, and I'm from Hudson, K-8. If I want to be an astronaut, what should I study in college?
Well, that's a great question, because the answer to that depends a lot on what you really love. What are you interested in? I mean, everybody that's an astronaut has a background in education in science or technology, engineering, or mathematics, and that covers a lot of different areas. I mean, we have astronauts that are geologists. They really like rocks. Chemists, physicists, medical doctors, engineers of any kind. I'm a mechanical engineer. We have, astronautical engineers. We have electrical engineers, lots of different kind of engineers too. And so the real answer for what you should study if you want my job is it depends on what you're really interested in, because you have to be interested in it in order to stick to it and to be one of the best. And that's what you really want to do, is do something you love and work at it really hard so you can be one of the best people ever doing whatever it is that you love doing. And that's how you have your best chance of taking my job in a few years.
My name is Maya Wilson from Inglewood K-8 School. How long have you spent in space and how long can you stay?
Oh, that's a great question, Milo. I've been up here this time 4.5 months in space, which is that's a long time for me. I flew twice on the space shuttle, and for those missions, that was just 2 weeks, and I thought those were long and really busy. And now this is really long to be up here 5.5 months. We've had people on the space station longer. The Russians have had people living in space for over a year, and so you could theoretically you could stay longer than 5.5 or 6 months, which is what we're planning for. But normally we don't do that because living in space is kind of hard on the body. It's hard on your bones, in your cardiovascular system, your heart and lungs. To be up here where it gets kind of lazy because my bones don't have to support my body. I'm just floating around. And so when I'm just floating around, my bones can get weak. Maybe floating around out of control. And so and the muscles don't have to do as much work up here because nothing weighs anything. It has mass, but it doesn't have weight. And so I can move things around that weigh 1,000 pounds. And as long as I move slowly, it's okay. So it's hard on the body to be up here for a long time, so we limit it to about 6 months.
My name is Jayla Glenn, and I'm from Hudson K-8 School. How often do you get to talk to your family from space?
Almost every day. We have different ways to do that. Every weekend, I get a video conference, just 15 minutes and sometimes longer, with my wife and one son that's at home, and the other kids if they're there. We also have a telephone. It's not a normal telephone like you have, but it's through the computers and stuff where I can actually call people. And so I call my family almost every day. I have the chance to call my family and say hi and talk about school and work and how things are going. So that's one way that we keep in touch. We also have email. And so it's not as fast as email. You can't trade emails. I can't send one and you can't receive it and answer me right back and then I get it and we have a conversation like that. It doesn't work that well, but it is a way of staying in touch with family and friends, which is important to us.
My name is Rashad Taylor from Carver High School, and my question is, have you ever encountered anything unusual while in space?
Would make for a good scene in a movie. I haven't seen anything like that. I've seen unusual things, though. I've seen the aurora borealis and australis, the northern and southern lights, are starting to become more active now. And that's a fascinating thing to see with your eyes up here, where you're not on the ground. You can see them in the northern parts of the United States. You can see it sometimes, or in the southern parts of the world. But up here, you have the chance to fly through those areas, and you can we actually fly through it. And it's a pretty strange thing with this incredible green kind of waving lights, and there's some red glowing in the atmosphere up above too, which is really cool. I think other than that, that's probably the coolest thing of all of a really cool phenomenon that I've seen from space.
My name is Kiera Victor, and I attend Carver High School. I want to know, why do astronauts wear spacesuits?
Hey, Kiera, good question. We wear spacesuits for the same reason when we're talking about why we don't, because there's a vacuum outside, there's no air outside, why we don't all get sucked outside and die. The spacesuit we wear for the same reason, to keep that air pressure around us. Our air pressure up here, where we're living and working in space, is the same as the air pressure around you right now in Alabama. and we keep it that way because that's where our bodies were designed to work at this kind of pressure and live at this pressure. The spacesuit is designed to keep the air pressure around our bodies to help keep us healthy. It also protects us from extreme cold or heat. I've done 7 spacewalks, and outside the temperatures can get plus and minus 200 degrees. If it's away from the sun, it gets really, really cold. And if the sun's shining on things, it can get 200 degrees or even hotter from the intense energy on it. So the spacesuit protects us from that environment, keeps us healthy.
My name is Marvell Rose, and I attend George Carver High School. My question is, how do the rockets get to space?
It's a good question, Margot. The rockets use thrust, and they generate a lot of energy, pushing out of the back of the rocket. And we combine a fuel and an oxidizer, and a simple way to think of it would be like gasoline and oxygen. It's not gasoline, but it's fuels that we're all familiar with. And you combine the two of them together, it makes an explosive mixture that burns really, really well and very, very quickly. If you have some gasoline or alcohol that's out, and you light it, and I'm not recommending that, you'll see that it burns and and mixes with air and stuff. Well, then when you mix the oxygen with it in that rocket engine, it creates, a tremendous reaction of force as those liquids are expanding then into hot gas, and the nozzle of the rocket kind of funnels that and directs it to push it down, and you're sitting up on top of it. And so that's a kind of force that's generated from that combustion of the oxidizer and the fuel, and then going through the nozzle of the rocket to push, and it's literally a push. I don't know the numbers for the Soyuz rocket. For the space shuttle, it weighs about 4.5 million pounds sitting on the ground. That's the space shuttle itself and the fuel tanks and everything else. And when it's leaving the Earth, it's pushing with over 7 million pounds of thrust. And so that's a tremendous amount of incredible energies involved to get us from sitting still on the surface of the Earth and into orbit around the planet in about 9 minutes. It's huge energies involved. It's a really cool stuff to learn more about.
My name is DeMarcus Bimbo, and I attend Dane Payne Middle School. Why are things different in space? For example, why do footprints stay on the moon?
Oh, that's a great question, Marcus. For the moon, I mean, what changes the Earth all the time? If you go out and put footprints in the mud today, sometime in the next week or two, the wind's going to come along, somebody else is going to come along and step on them, or a car's going to drive over them, or it's going to rain again, and it's going to wash it away. The moon doesn't have the kind of weather that we have here, because the weather depends on an atmosphere and rain and wind, erosion processes and things like that. That's why the moon has all these craters. If you look at the moon with a good set of binoculars, you can see these craters pockmarking the moon. It's really amazing. But the Earth is in the same space that the moon is in. So when we look at the Earth, and I look at the Earth, and I'm looking for these craters, and you can find some. There are many craters on the Earth, but they're barely visible. Most of them are just barely visible anymore because over time, the weather processes have kind of washed away or eroded away most of the big signs of these craters, as well as on the Earth we have plate tectonics, and that gets really complicated, where the plates that make up the surface of our Earth are shifting and grinding against each other over time. And so there's several things, but those footprints they leave on the moon are going to be there for a long time. And I think it's really kind of cool to think about the fact that there are still our human footprints on the moon, and someday we're going to go back up there and we're going to see the footprints and the tire tracks from the lunar rovers. And someday we're going to be putting human footprints on Mars, and that's a really cool thing too. But they're not going to stay on Mars because Mars has wind. It doesn't have much atmosphere. It's very thin, but it does have wind that kicks up big dust storms. So the footprints on Mars will make the history books, but they won't be there 100 years later.
Commander Fossum, thank you so much. We are just so thrilled to have this opportunity, and I know I speak on behalf of all those students here and Birmingham and Bessemer City Schools and Americans to say thank you for your service. Thank you so much for this opportunity. Let's show our support. Safe travels.
Oh, thank you very much. The children are amazing. Those were some awesome questions, some really good questions. I can tell they're really thinking, and I know that the purpose of this is to expose them to different ideas about the science and technology, engineering and math that are key to our future. There's a lot of things that they hear about in the world, and the key to figuring out some of these problems that they hear about in the news are really delving into the science and the technology behind these things to find out better solutions for a better tomorrow, and enjoy the adventures, because it is fun stuff. It's exciting stuff. I've really enjoyed talking to you, and now it's Mike Fossum on the International Space Station signing out.
Station, this is Houston ACR. Thank you. That concludes the event.
And thank you, Carver High School, Representative Sewell, and students. Station, we are now resuming operational communications.